hope you understood the previous class. If you didn't watch it, I'll just keep it right here. You can just watch it and understand the class. So, I gave a small question to do, and here is the answer of it. Let's jump into it. So, chapter 1, real numbers we are in. So, the question I gave was this: show that the square of any positive integer is of the form 5p, 5p plus 1, or 5p plus 4. So, as we have learned, Euclid division lemma, sorry, A is equal to BQ plus R. So, by comparing this with BQ plus R, what is B here? 5. So, what are the possible values of R when B is equal to 5? Possible values of R are 0, 1, 2, 3, and 4. So, we'll take each case and we'll substitute the R values in this place here, and we'll prove that square of A is in the form of 5p, 5p plus 1 and 5p plus 4, right? So first case, if R is equal to 1, then A is equal to 5q plus 0, because A is equal to bq plus R and R is equal to 0. So they have asked the square of that number. So we have to square A here. So A square is equal to 5q whole square, because 5q plus 0 is equal to 5q. And when A is equal to 5q, A square is equal to 5q square. Right? So 5q square. How to find 5q square? 5q square meaning is 5q into 5. So 5 into 5 is 25, and q into q is q square. So 25q square. How can we write this 25q square? You can write it as 5 into 5q square. Right? So let us take as 5q square is equal to p. Then it will be 5 into p, 5p. You have to write where 5q square is equal to p. Now, first case is done. When r is equal to 1, it is the square of any positive integer is 5p. Next, when r is equal to 2. If r is equal to 2, a is equal to, sorry, okay, r is equal to 0 here, my mistake. Then it will be r is equal to 1 here, sorry, I made mistake. So 5q plus 1, then square of that integer, 5q plus 1 whole square, 1. So identity a plus b whole square is equal to a square plus b square plus 2ab. What is a here? 5q is a here. What is b? 1 is b here. So 5q square whole square plus 1 square plus 2 into 5q into 1. So 5q square is 25q square. We already did here. 1 square is 1. And let us simplify this. 2 into 5q into 1. So 2, 5, 1 are real numbers here. So 2 into 5, 10. 10 ones are 10. And q. So plus 10q. I'm just gonna arrange the terms. 25q square plus 10q plus 1. So I'm gonna take 5 common in these two terms. So if I take 5 common, we'll get 5q square here and 2q here. And this plus 1 here. So let us take this 5q square plus 2q is equal to p here. Okay. So 5 into p, 5p plus 1. So where 5q square plus 2q is equal to p. Then if r is equal to 1, we've got the value as 5p plus 1. Next, third case, if r is equal to 2, then it will be a is equal to 5q plus 2. We have to square this integer, so a square is equal to 5q plus 2 whole square. Again, according to the identity, it is equal to 5q square plus 2 square plus 2 into a into b. So 5q square, we already did it, it's 25q square. 2 square is 2 2s are 4 plus, or what are the real numbers here? 2, 5 and 2. So 2 into 5, 10. 10 into 2, 20. So 20 and q here, 20q. So I'm going to rearrange the terms again. I'm going to 25, sorry, 25q square plus 20q plus 4. I'm going to take 5 common in this both terms. So 5 into 5q square plus 4q plus 4. So let us take this value as p. 5q square plus 4q is equal to p. So 5 into p plus 4 it is 5p plus 4, where 5q square plus 4q is equal to p. Now the third case, if r is equal to 3, then a is equal to 5q plus 3. Square of this integer, a square is equal to 5q plus 3 whole square. Then according to the identity again, 5q whole square plus 3 square plus 2 into 5q into 3. What is 5q square? It is 25q square. We have discussed above. 3 square is 3 3s are 9 plus 2 into 5 into 3. 2 5s are 10. 10 3s are 30. So 30 q here. So it is 5q square plus 9 plus 30q. We are going to rearrange the terms. It will be 25q square plus 30q plus 9. We can write 9 as what? We can write 9 as 5 plus 4, right? 5 plus 4 is 9. So we are going to take common 5 in these three terms now. So it will be 5 into 5q square plus 6q plus 1 and this 4 right here, 4. So let us take this value as p. 5q square plus 6q plus 1 is equal to p. Then 5 into p plus 4 it is 5p plus 4. It is 5p plus 4 where 5q square plus 6q plus 1 is equal to p. Now for the last case, fifth case, when r is equal to 4, then a is equal to 5q plus 4. It will be as squaring a square is equal to 5q plus 4 whole square. So according to identity, it will be 5q square plus 4 square plus 2 into 5q into 4, right? So 5q square is 25q square. We have discussed above. 4 square is 16 plus 2 5 is 10. 10 fours are 40. 40q. We are going to rearrange the terms again. 25q square plus 40q plus 16. Right? What can we write 16 as? We can write it as 10 plus 6. 10 plus 6. So now let us take 5 common in these three terms. If we take 5 common, we'll get 5q square plus 8q plus 2 plus 6. 6 is here. So let us take now this value as p. So 5q square plus 8q plus 2 is equal to p. So if this is equal to p, then 5 into p plus 6, it is 5p plus 6. So where 5q square plus 8q plus 2 is equal to p, then it is 5q plus 5p plus 6. So we are going to write the statement from the question like square of any positive integer is of the form 5p, 5p plus 1 or 5p plus 4. What are you going to write? The square of any positive integer is in the form of 5p, 5p plus 1 or 5p plus 4. You can see it, right? Sorry, we can write 16 as 15 plus 1 here, right? You can write 16 as 15 plus 1. Then this is going to be 3. This is going to be 1. So it's going to be 1 here again. And so this is going to be 3. So we can see that when we square a here, we get 5p, 5p plus 1, 5p plus 4, again 5p plus 4, and 5p plus 1. Right? Right. So let us do another different type of sum. Right? Question is show that 1 and only 1 out of n plus 2 or n plus 4 is divisible by 3 where n is any positive integer. You'll understand when we do the sum. So as they told it should be divisible by 3, we'll take as b is equal to 3. What are the possible values of r when b is equal to 3? R is equal to 0, 1 and 2. Right? Yes. So case 1, when r is equal to 0. By division algorithm, a is equal to bq plus r. Then n is equal to 3q plus 0 because r is equal to 0. They're told to check with n. So here a is going to be n. Okay. So 3q plus 0 is 3q. What is the next one? N plus 2. N plus 2 is equal to 3q plus 2. Of course, right? When n is equal to 3q, n plus 2 is equal to 3q plus 2. It will be 3q plus 2. When the third one, n plus 4, right? 3q plus 4. 3q plus 4. N is equal to 3q plus 2. N plus 4 is equal to 3q plus 4. Now rough column. Let's take q as any natural number. Let it be 5. Sorry for that. Let it be 5. So 3q. That means 3 into 5. 3q. It is 15. Is 15 divisible by 3? Yes, it is divisible by 3. Divisible by 3. Next one, 3q plus 2. So 3 into 5 plus 2. 3 5s are 15 plus 2 it is 17. Is 17 divisible by 3? No, it is not divisible by 3. Right? 17 is not divisible by 3. So you'll write as it is not divisible. Next, 3q plus 4. 3q, 3 into 5 plus 4. 3 5 is 15 plus 4, it is 19. Is 19 divisible by 3? No, it is not divisible by 3. Next case. What is next case? When r is equal to 1, then n is equal to 3q plus 1, right? 3q plus 1. Next, n plus 2 is equal to 3q plus 1 plus 2, because when n is equal to 3q plus 1, n plus 2 is equal to 3q plus 1 plus 2, right? It will be 3q plus 3. Next, n plus 4, the final one. Then it's gonna be 3q plus 1 plus 4. Then it's gonna be 3q plus 5. Again, rough column. Now let's take q is equal to 7, or let's take it as 6, right? So what is the first one? 3q plus 1. 3 into 6 plus 1. 3 6 are 18 plus 1, 19. Is it divisible by 3? Is 19 divisible by 3? No, not divisible by 3. Next one, 3q plus 3. 3 into 6 plus 3. 3 6 are 18 plus 3. 18 plus 3 is 21. Is 21 divisible by 3? Yes. 3 sevens are 21. So 3q plus 3 is divisible by 3. Next, the final one, 3q plus 5. 3 into 6 plus 5. What is 3 into 6? These are 18 plus 5. What is 18 plus 5? 18 plus 5, 23. Is 23 divisible by 3? No. So 3q plus 5 is not divisible by 3. Next, the final case, case 3. When r is equal to 2. So when r is equal to 2, n equal to 3q plus 2. A is equal to bq plus r is equal to 2. Next, n plus 2. Then it will be 3q plus 2, which is 3q plus 4. Finally, n plus 4. It's going to be 3q plus 2 plus 4. It's going to be 3q plus 6. So rough column again. What do you want q now? Let's take it as 8. Okay, 8. So first one is 3q plus 2. Q is equal to 8. So 3 8s are 24 plus 2. It's 26. Is 26 divisible by 3? No, it is not divisible by 3. Next, 3q plus 4. Is 3q plus 4 divisible by 3? Let us see. Again, 8 is q here. Plus 4, that's 24 plus 4, 28. Is 28 divisible by 3? No, not divisible by 3. So 3q plus 4 is not divisible by 3. Next, 3q plus 6, right? 3q plus 6. So 3 into 8 plus 6, that's 24 plus 6. It is 30. Is 30 divisible by 3? Yes, it is divisible by 3. Now let us read the question again. We'll understand it now. Show that 1 and only 1 out of n plus 2 or n plus 4. 1 and only 1 out of n plus 2, n plus 4. See, only 1 is divisible by 3. Is divisible by 3. Again, read the question. Show that only 1 and only 1 out of n plus 2 and n plus 4 is divisible by 3. Again, show that only 1 and only 1 out of n plus 2 and n plus 4 is divisible by 3. So what we're going to write the therefore statement as? Therefore, 1 and only one out of n plus 2 or n plus 4 is divisible by 3. That's the answer, right? So, we have finished all the topics in Euclid division lemma. So, let's come to the second topic of the mind map which I created in the first video. So, it is prime factorization and finding LCM HCF through prime factorization. So, let us prime factorize some numbers here, okay? First number 8, 2, 3, 2. Let's prime factorize these numbers. So what is prime factorization? It is a factorization of number only using prime numbers. So we'll make it like this 8232. And what is the first prime number in which this can divide 8232 can divide 2. So what is 8232 divided by 2? 4, 1, 1 and 6, right? So it is 4116. Again, next one. What is the number which prime number can divide 4116 least prime number? 2 again. 4116 divided by 2, we get, sorry, 2s are 4, 1 here, we add 0, we get another number 1, 5s are 10, minus 10, 1, 6, 2, 6 are 18. So it is 2058. Again, what is the least prime number which can divide 2058? It is again 2. So 2058 divided by 2. 2 tens are minus 20, we get 5 here. 2 twos are minus 4, we get 18 here. 2 nines are 18. So it will be 1029. Next, what is the least prime number which can divide 1029? It is not 2. Can you divide 1029 by 2? No, you will get decimals. So what is divisibility rule of 3? Adding all the numbers, if the addition of all numbers is divisible by 3, the whole number is divisible by 3. So 1 plus 0 plus 2 plus 9, it is 12. 9 plus 2 is 11. 11 plus 1 is 12. So is 2 divisible by 3? Yes, 3 4s are 12. So the whole thing 1029 is actually divisible by 3. So let's divide it. 1029 divisible by 3. 3 3s are 9. We get 1, 2, 4s are 12, 9, 3 3s are 9. We get 343 when divided by 3. Can you divide 343 by 3? Let us add the numbers. 343, 3 plus 4 plus 3. 3 plus 4 is 7, 7 plus 3 is 10. Can divide 10 by 3? No, we cannot divide 10 by 3. So what is the next least prime number which can divide 343? We have 2, 2, 3, 5, 7. We can't divide 343 by 5. So next number is 7. Right? So let us see if it is divisible by 7. 343 divisible by 7. 7 fours are 28. We get 63. Nines are 63. 0. So it is 7. We get 49. Again 7 sevens are 49. So we can write 8232 as 2 into 2 into 2 into 3 into 7 into 7 into 7. How can we write 2 into 2 into 2 in exponential form? 2 into 2 into 2 is 2 is equal to 2 power 3, right? So it is equal to 2 power 3 into 3, and 777 is 7 power 3. So 2 cube into 3 into 7 cube is the prime factorization of 8 to 3. Let's do another number. 140, right? 140. 2s are we get 70, 2s are we get 35. We cannot divide 35 by 2 or 3. So next number 5. 5 sevens are 7 is again a prime number. So we don't need to divide it. So 140 is equal to 2 into 2 into 5 into 7. 2 into 2 is 2 power 2 into 5 into 7. Another number 156. 156 is divisible by 2. It is 78 times. Again it is divisible by 2. 39 times. 39 is not divisible by 2. So next number is 3. We get 13. What are the prime numbers? 2, 3, 5, 7, 11, 13. So 13 is a prime number. So we don't need to divide it again. So 156 is equal to 2 into 2 into 3 into 13, which is equal to 2 into 2 is 2 power 2 into 3 into 13. So um, you can do these numbers. Let us see which numbers. You do 13915 and 1176. Okay. Yes, I know you can do. I hope you understood today's class. Just do the extra sum I have given. I will give the solution of it in the next class. Subscribe so that you don't miss the answer of it. And signing off, Gyan, Sagar. And thank you.